Hello everyone, myself Professor Deepali Vagode, and today my topic is generation of plane curves. So these are the topics I am going to cover, that introduction, curve representation, parametric representation of circle, generation of endpoints on the circle and algorithm, and then I am going to solve some examples. So a little information about generation of plane curves. So generation of plane curves is an important topic in engineering, graphics and mechanical engineering. A plane curve is a curve traced by a point moving in a single plane according to a definite law. These curves are generally generated using simple geometric constructions or mechanical movements such as rolling, rotation and sliding. So some of these transformations we are going to apply on these plane curves. So plane curves play a vital role in the design of machine elements like gears, cams and linkages, where accurate motion and power transmission are required. Understanding the principles of generation of plane curves helps engineers analyze motion, design efficient mechanisms and solve practical engineering problems. So the next topic is curve representation. A plane curve is a curve that lies in a single plane. A plane curve may be closed or open. Some of the most common open curves are the line, parabola and hyperbola, and some of the most common closed curves are the circle and ellipse. So here you can see in this figure that line, parabola and hyperbola, these are the open curves, and the circle and ellipse, these are the closed curves. A curve may be represented as a collection of points, provided that the points are properly spaced and are connected by short straight line segments. So there are many points on the infinite number of points on this line. So this line is generated by connecting the points by straight lines. So parametric equation of Cartesian coordinates of a point P of x comma y on the curve is x is equal to x of t and y is equal to y of t, where t is a parameter. So these are some applications of plane curves, where the plane curves are used in engineering, and the parabolic curves are used in the design of suspension and arc bridges because they distribute weight efficiency and reduce stress. In aeronautics, airfoils are shaped using splines and Bezier curves to generate lift and minimize drag. In computer graphics, plane curves make it possible to represent complex shapes and animations in two-dimensional space. In physics, plane curves provide a mathematical framework for modeling planetary motion and other physical phenomena. These examples show how versatile and valuable plane curves are in solving problems and driving innovations. So the next point is parametric representation of circle. So the analytical equation of a circle with center at origin 0, 0. Origin that means where the x and y axis intersect each other, that point is 0, 0 and the radius is r. So the analytical equation is x square plus y square is equal to r square. So this is the circle whose center is 0, 0, that is called as origin, and with center at h comma k and radius r. So this is the random point which is the center of this circle, say h comma k. So the analytical equation of this circle is x square plus y square is equal to r square, and the analytical equation of this circle is x minus h whole square plus y minus k whole square is equal to r square. Now the parametric equations of the circles. So the parametric equation of circle whose center is origin is x is equal to r cos theta and y is equal to r sin theta. That means the x coordinate is calculated by this formula and the y coordinate is calculated by this formula, where theta, that means the angle, lies in between 0 and 2 pi. Similarly, the parametric equations of circle whose center is at point h comma k is x is equal to r cos theta plus h and y is equal to r sin theta plus k, and here theta is the parameter. Now generation of n points on the circle x square plus y square is equal to r square. So here we are going to see the recursive formula to find the coordinates of the points on the circle. So consider this figure. Here the initial angle is theta is equal to 0. Then the points are equally spaced. Suppose this is the ith point, this is the I plus 1th point. So pi is having the coordinates r cos theta I and r sin theta I. Then pi plus 1, it is having the coordinates r cos theta I plus 1, r sin theta I plus 1. Here the initial angle is 0 and there is an equal increment by delta theta. So the initial angle theta is equal to 0 degree and measure of angle XOPI is theta I, and the measure of angle XOP I plus 1 is equal to theta I plus delta theta. That means there is an equal increment in the angle theta, that is it is given by delta theta. So at the point pi whose coordinates are xi, yi, we have xi is equal to r cos theta I and yi is equal to r sin theta I. And at the point pi plus 1 whose coordinates are xi plus 1, yi plus 1, we have xi plus 1 is equal to r cos theta I plus delta theta and yi plus 1 is equal to r sin theta I plus delta theta. Now xi plus 1 is equal to r cos theta I plus delta theta. Now the expansion of r cos A plus B, cos A plus B is equal to cos A cos B plus sin A sin B. So we can use this formula. So this is equal to r into cos theta I cos delta theta plus sin theta I sin delta theta. So multiplying by r, we get r into cos theta I into cos delta theta plus r into sin theta I into sin delta theta. Now r cos theta I and r sin theta I, these are the values of xi and yi. Xi cos delta theta plus yi sin delta theta. This is from equation 1, where xi is r cos theta I and yi is r sin theta I. So this is the x coordinate. Now find out the y coordinate, that is yi plus 1, and this is equal to r sin theta I plus delta theta. So here we can use the formula sin A plus B is equal to sin A cos B minus cos A sin B. So this is equal to R into sin theta I cos delta theta minus cos theta I sin delta theta, and multiplying by R we get R sin theta I cos delta theta minus R cos theta I into sin delta theta. Now R sin theta I and R cos theta I. So this is, now what is R sin theta I? It is yi. So yi cos delta theta minus R cos theta I is xi sin delta theta. So this is the y coordinate. So we have the x coordinate and y coordinate of the next points. So we can combine them, xi plus 1 yi plus 1 equal to xi cos delta theta plus yi sin delta theta, and the y coordinate is yi cos delta theta minus xi sin delta theta. So if we write it in terms of the matrix multiplication, then we get xi yi into cos delta theta sin delta theta minus sin delta theta and cos delta theta, and here I varies from 1, 2, 3 up to n number of points. So this is the recursive formula to generate the equally spaced n points on the arc of the circle. So we have to solve the example step by step. So let us see the algorithm to generate the n equally spaced points on the circle whose center is h comma k. So the equation is x minus h whole square plus y minus k whole square is equal to r square. So first we generate the n points on the circle. We cannot directly generate the points on the circle whose center is h comma k. So we have to first generate the n points on the circle at origin whose center is 0, 0 and the radius is r. Then second we have to find the increment angle delta theta. It is calculated by the formula theta max minus theta min upon n. So for the circle whose center is origin, we have theta max is equal to 360 degree and theta minimum is 0. So 360 degree upon n. So if the circle is closed, and the formula to calculate delta theta is theta max minus theta min upon n minus 1 if circle is open arc. Now next the initial point is calculated using the formula x1 y1 is equal to r cos theta min r sin theta min, that is equal to r 0 if the circle is closed. Initial point is r 0. Then next use the recursive formula to find remaining points. So we use the recursive formula just generated, then form the matrix X for all the points. So and then if the center is at point h comma k, then we translate the origin h comma k using this translation matrix 1 0 0 0 1 0 h k 1, and then the required points on the circle are x star is equal to x into t. So the matrix we formed X, we apply the translation matrix on that matrix to get the required points on the circle whose center is h comma k. So let us solve this example. Obtain uniformly spaced 4 points on the circle x square plus y square is equal to 1. So if we compare this equation, with x square plus y square equal to r square, we get r is equal to 1 and number of points n is equal to 4. Here we have given the number of points. Then calculate the incremented angle, that is delta theta. As the circle is closed, the delta theta is calculated by theta max minus theta mean upon n. So as the circle is closed, we have theta max, that is 360 degree, and theta minimum 0 degree upon number of points 4. So 360 degree divided by 4, that is equal to 90 degree. That means the points are equally spaced by the angle 90 degree. Then initial point. The initial point, as the circle is closed, so we have initial point x1 y1 is equal to r0. Now r is 1, so the initial point is 1 0, and then use the recursive formula to generate the remaining points, that is xi plus 1 yi plus 1 equal to xi yi into cos delta theta sin delta theta minus sin delta theta and cos delta theta. So xi yi into cos 90 sin 90 and this is equal to xi yi 0 1 minus 1 0, as cos 90 is 0, sin 90 is 1 and minus sin 90 minus 1 and cos 90 is 0. So we can use this recursive formula. Suppose this is equation 1 to generate the remaining points. So x1 y1 is 1 0 into 0 1 minus 1 0. So the matrix multiplication gives 1 into 0, 0 into minus 1, that is 0, 1 into 1 and 0 into 0 is 1. Our next point 0 1. So x3 y3 is calculated using x2 y2. So again put the values in the recursive formula, 0 1 and 0 1 minus 1 0. So after matrix multiplication we get 0 into 0, 1 into minus 1, so minus 1 and then 0 into 1 into 0, that is 0. So our next point is minus 1 0 and then x4 y4 so it is x3 y3 into again the matrix 0 1 minus 1 0. So x3 y3 is minus 1 0 and 0 1 minus 1 0 and this is equal to, now the product is again minus 1 into 0 0, 0 into minus 1 0, then minus 1 into minus 1, minus 1 into 1 and 0 into 0. So our next point is 0 and minus 1. Now form the matrix X of all the points. So our initial point is 1 0, then x2 y2 is 0 1, x3 y3 minus 1 0 and x4 y4 0 minus 1. So these are the 4 points on the circle x square plus y square is equal to 1, which are obtained by using the recursive formula. So here we can clearly see that as the angle is 90 degree and this is the starting point, and after rotation this is our ending point. So here initially angle was 0 and after completion it was 360 degree. So here our initial point is 1 0, and as the angle is 90 degree, so second point will be here where the coordinates are 0 and 1. Again the third point will be here, that is minus 1 and 0, and the fourth point will be here 0 minus 1. Now let us see another example. Obtain uniformly spaced 3 points on the circle x square plus y square is equal to 4 in first quadrant. First quadrant, that means here we have to find the number of 3 points on this portion of the circle. This is x axis, this is y axis. So again we have, if we compare this equation with x square plus y square is equal to r square, we get r is equal to 2 and the number of points n is equal to, we have given as 3. Then calculate delta theta, delta theta. Now the curve is open arc, here theta max minus theta min upon n minus 1, because the curve is open arc, so we take n minus 1. Now here the theta max is 90 degree and theta minimum is 0 degree, because the curve lies in first quadrant. In first quadrant, so the initial angle is 0 and the final angle is 90 degree. So 90 degree minus 0 degree upon n minus 1, that is 3 minus 1. So it is 45 degree. Now the sine 0. So cos 0 is 1. So the initial point is 2 and sine 0 is 0. So the initial point is 2 0. Now use the recursive formula to find the remaining points xi yi into cos delta theta sin delta theta minus sin delta theta cos delta theta. So xi yi. Now the delta theta is 45 degree. So cos 45 degree, sin 45 degree minus sin 45 degree and cos 45 degree. So xi yi, xi plus 1 yi plus 1 is equal to xi yi into cos 45 degree is 1 upon root 2, sin 45 degree is again 1 upon root 2, 1 upon root 2. So minus 1 upon root 2 and 1 upon root 2. So this is our recursive formula. Now we have to generate 3 points. Our first point is initial point. So x2 y2 is equal to x1 y1 into 1 upon root 2, 1 upon root 2 minus 1 upon root 2 and 1 upon root 2. And that is equal to x1 y1 is 2 0 So multiply this row by first column. So 2 into 1 upon root 2 and 0 into minus 1 upon root 2. So it is only root 2. Again 2 into 1 upon root 2 and 0 into 1 upon root 2. So it is root 2. So this is our second point. And the third point x3 y3 is equal to x2 y2 into 1 upon root 2, 1 upon root 2 minus 1 upon root 2 and 1 upon root 2. So x2 y2 is root 2 root 2. And after multiplication, root 2 into 1 upon root 2 is 1 and root 2 into minus 1 upon root 2 is minus 1. So the first coordinate is 0, then root 2 into 1 upon root 2 is 1 and root 2 into 1 upon root 2 is 1, that is 2. Therefore x is equal to, here we can put x1 y1, x2 y2, x3 y3, that is equal to 2 0, then root 2 and 0 0 and 2. So here this is 2 comma 0, here root 2 and this is 0 comma 2. So these are the 3 uniformly spaced points on the arc of the circle in first quadrant. Now the next, obtain uniformly spaced 6 points on the circle whose center is 1 and 2 minus 2 as the equation is x minus 1 whole square plus y plus 2 whole square is equal to 4. So if we compare this equation with x minus h whole square plus y minus k whole square is equal to r square, we get h is equal to 1 and k is equal to minus 2 and r is equal to 2. Now first we generate the uniformly spaced 6 points on the circle at origin. So calculate delta theta. Delta theta is equal to again theta max minus theta minimum as and divide by n as the circle is closed arc. So here theta max is 360 degree and theta minimum is 0 degree divided by number of points, n is equal to 6. So 6, so it is 60 degree. Delta theta is 60 degree and the initial point x1 y1 is equal to r cos theta minimum r sin theta minimum. So as our theta minimum is 0 degree, so r and r is 2, so we get the initial point as 2 0 and the remaining points are calculated using xi plus 1 yi plus 1 is equal to xi yi into cos delta theta sin delta theta minus sin delta theta cos delta theta. As delta theta is 60 degree, so we put the values xi yi cos 60 degree sin 60 degree minus sin 60 degree and cos 60 degree. that is equal to xi yi into cos 60 degree is 1 upon 2 root 3 by 2 minus root 3 by 2 1 upon 2, that is xi yi into suppose t, and this is equation 1. So this is our recursive formula. This is our recursive formula to generate the next remaining 5 points. Therefore, x2 y2 is equal to x1 y1 into t. So our x1 y1 is 2 0 and 1 upon 2 root 3 by 2 minus root 3 by 2 and 1 upon 2. So after multiplication, 2 into 1 by 2, 0 into minus root 3 by 2. So 2 into 1 by 2 is 1, and then 2 into root 3 by 2, 0 into 1 by 2. So we get root 3. This is our second point. Then x3 y3, x2 y2 into t. Now x2 y2 is 1 and root 3 into 1 upon 2 root 3 by 2 minus root 3 by 2 1 upon 2. So after multiplication, here we get 1 by 2 and minus 1 by 2 minus 3 by 2, and then 3 by 2 plus 3 by 2 root 3 by 2 plus root 3 by 2, and this is equal to minus 1, and this is root 3, minus 1 and root 3, because it is 2 root 3 upon 2. So 2 get cancelled, we get minus 1 and root 3. So similarly, we can calculate the remaining points x3 y3. We get minus 1 root 3, x4 y4 we got minus 2 0, x5 y5 minus 1 minus root 3, and then x6 y6 1 and minus root 3. So in this figure, you can clearly see that this is the initial point. After 60 degree, the point is here, and then the here and here and here. These are the 6 points on the. So I form the matrix X. So X is equal to x1 y1 is 2 0, x2 y2 is 1 root 3, x3 y3 is minus 1 root 3, x4 y4 minus 2 0, then minus 1 minus root 3 and 1 minus root 3. Now to find the points whose center is on the circle whose center is 1 and minus 2, we use the translation matrix T as 1 0 0 0 1 0 1 minus 2 and 1. Therefore, we will get x star is equal to x into t. So this is x. Now as the matrix is 3 by 3, we have to add the homogeneous coordinates here. So 1 0 0 0 1 0 and 1 minus 2 and 1. So after multiplication 2 plus 1 that is 3, and minus 2 1, then second point 1 plus 1 2, then root 3 minus 2, and then 1, then minus 1 and 1 plus 1 0, then root 3 minus 2, root 3 minus 2 and 1 and then fourth point minus 2 plus 1 that is minus 1, then 0 either minus 2, minus 1 minus 2 and 1 and then fifth point is minus 1 plus 1 0, and then minus root 3 minus 2 and then 1, and the last point is 1 is 0 and 1 plus 1 2 minus root 3 minus 2 and 1. So these are the 6 equally spaced points on the circle whose equation is this. So in this way, using the recursive formula, we can find the number of points, equally spaced number of points on the circle at origin, as well as the circle whose center is at the point h, k. Thank you.